Yeah, I love best thing in the world.
Yes, yeah. The only problem with the exam is that there's not 6 Kirchhoff questions in section B.
The only problem is that they have Kirchhoff questions.
It's okay. Right, part 1. What is Kirchhoff's first law?
The sum of the parallel equals 0.
Yeah, is it loop? Well, it doesn't matter if we get backwards, I suppose. There's loop first, and then loop, which is the voltage one, and then junction. Yeah, which one did we do first last time? Loop. So first law is the sum around any loop of the voltages should total 0.
Can I just write that?
Thank you. First rule is the junction rule. The sum of the currents in the junction is 0.
Can I just write that instead of the word?
1 mark. Yeah, for 1 mark it's okay. What conservation is this? This is the conservation of charge. Part 3, the second law. The sum around any loop of the voltages equals 0, and this is a conservation of what?
You said that already, Peter.
We did. I mean, they're very similar. And I think I might have done one just like this in class, if not this one. So let's see how quick we can do it. Right, so it's part A done.
This.
What?
Yeah, we've done this.
Yeah, okay, well, I'm doing it again.
No,
Sure.
we would have done exactly this one.
Yes, and I'm doing it again.
Why?
Don't know.
We have a serious problem.
What's a serious problem? We're doing it again. What's that? Yeah, just do it. Yeah, thank you, just do it. Let's see how quickly we can just do it in. So part B now. Simplify and redraw the circuit. Okay. So some of these resistors can be added together. Hurry up and write this down. Okay, B part. Right, so some of these resistors can be added together. I can definitely add the 7 and the 2 together. What else can I add?
6 and 3.
The 6 and the 3, yeah. And then here there is a battery. And then here is a battery. And then here the 3 and the 6 go together. Okay, so the voltages in red. 7 volts, E volts, 11 volts. The resistance here is 8. This one here I can get it. I add 2 and 2, so that's just 4. And then this one here is 1 over 3 plus 1 over 6. 1 over 3 plus 1 over 6. And then that's a 2. Right, that's part 1 done. Part 2 is calculate everything, basically. So I'll use, I should draw in my currents. Okay, to call this one I1 and this one here I2. So that's still I2, I2. Okay, and here's I1, I1. Okay, yeah, I1, and then this is I2. Oh, and they give us the one in the middle here. The one in the middle is 0.5. 0.5. Okay, so if I use the junction rule here, I get 0.5 minus I1 minus I2 equals 0. So therefore, I1 plus I2 equals 0.5. Now let's use the loop, and let's take this one. 7 minus, now 7, does this add or subtract? The battery's the wrong way around, isn't it? So it acts like a resistor, so I subtract. So 7 minus 0.5 E minus 4 Oh, sorry, thank you. That would have saved so much pain later. Minus E minus 4 minus 4I1 equals 0. So I get here 4I1 plus E equals 3. Okay, and now the last loop, we'll take it, what's wrong? Huh? Which 4? This 4?
Yeah.
Sorry, it should be 2, should it? No, this 4. 0.5 times 8 is the voltage in that resistor, IR. Yep. Alright, last one. Which loop will I take? I could take the loop on the right, or I could take the outer loop.
Right.
Well, this one on the right is smaller, isn't it? But if I took... I guess that doesn't actually matter so much, does it? So I'll just take the smaller one. Okay. So I have now... No, I'll start at the 11. 11 plus or minus the E, minus E, minus 4, minus 2I2 equals 0. 11 minus E, minus 4, minus 2I2 equals 0. So I get 2I2 plus E equals 7. Now they're very nice to solve because I can put these two together to get rid of the E. So I can have 4I1 minus 2I2 equals minus 4. And I can put that together with that one. I'll just multiply this by 2. 2I1 plus 2I2 equals 1. Add them together, and I get 6I1 equals minus 3, so I1 equals minus 0.5. I can put that in there to get I2, or actually, sorry, I can put that in there to get I2. So I2 is 0.5 minus I1, so that's 1. And then I can put both of those answers into, I can put I1 into here to get E. So E is 3 minus 4I1. So that would be 5. I don't know, I'm doing a bit in my head. Can you give me the answers, please, if you have them there soon? B part 2, part 3. Great. And then the last part now? No? Yes? What?
I missed the step from I1 to
Sorry, I'm not backtracking, Tanish. You'll have to catch the video. I'm sorry. Okay. Part 3 is, what is the quantity of electrical charge flowing between B and A along the 8 ohm resistor in 2 minutes? Okay. So what's charge? It's IT. What's the I? Well, it says it there in the question. It's 0.5. And what's the T? Yeah. So what's this? 60 coulombs. Okay. And then the last part is, what is the voltage between B and A? Okay. Now, I'll just redraw that here. Here is this battery here, and then here is this resistor. This battery is E, which is 5 volts, and then this here is 8 ohms. And, yes, okay, 8 ohms. If we connect the voltmeter here, what the voltmeter works out is the voltage here and the voltage here and adds them together. This is V would equal I or which would equal 4 volts. So the question now I'm going to ask you is, will the answer on the voltmeter, will it be 4 plus or minus 5? In other words, how do these combine to get the voltage? Do we add or subtract? Add. If I turn the battery around, my voltmeter would say 1. Don't worry about the plus or the minus. So if I had them like this, it would say 9, and if I switch the battery, it would say 1. And the reason for this is, remember, that battery is acting like a resistor, because it's the wrong way around in the circuit. So it's taking voltage, just like the resistor is taking voltage. So together, they're like one large resistor, so to speak. So it should be 9. I really hope it's 9. What's the answer? 9? Alright, just collected another 20 marks.